Alright, so there are many practical use cases where you'd want to know when you have scrolled beyond a certain limit inside an application. For example, if you want to lazy load the content as the user progresses through the application, or say you'd want to implement something like an infinite scrolling section like you see on Instagram, where you'll have to know when to fetch the next batch of items. So what someone would want to look for if they want to implement something like these examples would be an observer that could detect when a specific element intersects the viewport. And that's exactly what the intersection observer API will help us achieve. This API provides a way to observe when a specific target element intersects with an ancestor element, which most of the time is like a container for this target. And if there is no container mentioned explicitly, then the viewport itself is considered as the container. The API lets us register a callback function that gets executed whenever the element that we wish to monitor enters or exits this container. So in the case of infinite scrolling, when the last or even the second to the last element intersects the container, you can call the API to fetch the rest of the items inside the callback function. The container is also called the root element, so I might use these terms interchangeably throughout this tutorial. So yeah, just keep in mind that both these terms are the same. Now if you watch my previous video on mutation observer, you'll find some similarities when it comes to initializing these observers. We'll create an observer using the intersection observers constructor. It takes two arguments. The first one is the callback function and the second argument is an options object. Let me just go inside the script file and we'll right away create the observer. The options object passed inside the constructor lets you control the circumstances under which the observer's callback will be invoked. So basically there are three options. The first option is called the root and it acts as the viewport for checking the visibility of the target element. Now this root element, if not specified, defaults to the browser viewport. Also, while it's pretty obvious, this root element has to be an ancestor of the target element. The second option is root margin. It's like a virtual margin that gets added to the root element. The intersection boundary will be calculated by adding or subtracting this margin. You'll get more clarity when we look at this later in an example. And yeah, by default, the value of this root margin is set to 0. The third option is the threshold. This threshold is the percentage of the target's visibility at which point the observer's callback gets executed. So for example, if you want the callback to be triggered once 50% of the target is visible, you set the threshold to 0.5. The threshold value ranges from 0 to 1, 0 being 0% and 1 being 100%. The default, by the way, is 0, so when the first pixel of the target element is visible, the callback will get fired immediately. You can also pass in an array if you want the callback to run at multiple intervals. For instance, if you want the callback to be fired every time the visibility of the target element crosses 25%, then you'd set the threshold to this array that you see over here. So for now, we'll stick to the default values of all the options, which means that the root will be the viewport, the root margin and the threshold will be set to 0. Finally, this observer needs to observe a target element. So let's assume we have a block with an ID of target inside our HTML. So I'll just create a div element and I'll give it an ID. Now I'll also add some styles for this block. Inside the script, let's first create the callback function. It will have a bunch of intersection entries and for now we'll just simply log them in the console. We can then use the observe method that is present on this observer instance. And it will take the target element. So the target is document.querySelector. Now if I run this in the browser, we'll find this red box which is our target element. If I open the console, you'll find this intersection entries array that we are logging inside our callback. Let's open it up and see what we have inside. So this intersection observer entry gives you the information of the intersection that happens between the target element and the container. It has a bunch of properties here. The bounding client rect or the intersection rect or even root bounds are all DOM rect objects. So DOM rect is a geometry interface that gives you the size and position of a rectangle. All the elements inside your web application, no matter what shape they look like, ultimately are contained inside a rectangle. So if I turn up the border radius of our div to 100%, even though it looks like a circle, it's still a DOM rect. You'll see that it's still contained inside a rectangular structure. An element with a more bizarre structure, as you can see on the screen, would still fall under DOM rect. Let's take the easiest one first, which is root bounds. Root bounds will give you the size and position information of the root, which in this case is the viewport itself. My current viewport size is about 906 cross 760. If I zoom in or zoom out inside this viewport, or maybe switch to a different kind of a viewport like a mobile view, then these values will change. The top is set to 0, the left is set to 0. The right and the bottom values will be the viewport limits. X and Y, again, that you see over here are just like top and left, so they'll also be set to 0. The bounding client rect, which is the first one here, gives you the size and position information of the target with respect to the viewport. So again, you can see the same set of properties that was present inside root bounds. The bottom is going to be 100 because the height of this box is 100. Similarly, the right is also going to be set to 100. Left and top will be set to 0. X and Y, again similar to left and top, will be set to 0. The height and width, as we had set it ourselves in the CSS, is set to 100. Finally, the intersection rect will give you the size and position of the visible bit inside the root. So if the target element is completely inside the root, as we have in our example, it's fully visible inside this viewport, then the intersection rect will be the same as bounding client rect. You can see here that the values are exactly the same. If some part of this target element is present outside this viewport, then the values inside intersection rect will be different from bounding client rect. Now let's move this block below this viewport height to test a few things out. So inside the CSS, let me just set the position of this target to relative, and I'll set the top value to 1000 pixels. Now you can see that the target is outside this viewport. It's not present inside these 4 walls. Let me just reload this once. Now if you notice, we get an entry even though the element is not visible. That's because the moment we assign a target to our observer, so inside the script file, the moment this happens, the target gets assigned to this observer, the callback gets fired once. It doesn't matter if the target is visible in the viewport or not, the callback gets fired once during initialization, so keep that in mind. Now let's slowly scroll down and see when the intersection is detected. Yeah, you can see here, since some part of the div is now visible and is part of the viewport, we get an intersection observer entry. Now if I look inside this, I'll open up the intersection rect directly. You'll see that the bottom value is 906 pixels. This will always be equal to the container's bottom value, because whenever these two intersect, the intersection rectangle will prune everything beyond the container. So if I open up the root bounds object, you'll see that the bottom value is same as that of the intersection rect. So basically, if the target intersects on the right side of the viewport, then the intersection rect's right will be equal to the container's right, if that makes sense. The height is about 2.5 pixels. The height that you see here might actually be more than 2.5 pixels. The height that we get inside this entry was recorded when the intersection happened and the callback was fired. It could very well be possible that I might have scrolled a little bit extra and this height might not match what we see over here. The left and right values will be 0 and 100. No problems with that. The top value will basically be the bottom value minus the height. So 906 minus 2.5 whatever is going to give you the top value. X and Y again will be equal to the left and top values. So these 3 DOM rect objects are very important for you to understand: the intersection rect, the root bounds, and bounding client rect. Rest everything is pretty straightforward. The intersection ratio is the amount by which the target element intersects the root. This is in percentage, so 0 being 0 and 1 being 100. So for this example, it's about 2%. The is intersecting property will tell you whether the target is intersecting the root or not. The is visible property might not even be part of this API. I'm guessing it's going to be added in a future implementation, because if you look at the docs for the intersection observer entry in MDN, you won't even find this is visible property. So yeah, maybe it's part of a future implementation. If anything related to this comes up, I'll try to update it in the comments. The target is the DOM node for our div element, and the time property is when the intersection occurred since the observer was registered. Alright, so let's quickly look at the options for the intersection observer. The first one was the root. So currently we do not pass anything in this option, which is why it defaults to the viewport. So yeah, let's create a container now. This container has to be an ancestor of the target. So let's just wrap our target with this container. Let's set the height, width and background for this container as well. Also for now, let's comment out this position and the top value for our target element. Now inside the script, let's add the container as the root. So root will be set to document.querySelector. Now I'll save this and go back to the browser. Now if I open this entry, you'll see that the root bounds have now changed and they are the dimensions of this container element. Now let's again set the position of this target element back to relative, and we'll set the top to 250 pixels. So I'll uncomment this and I'll change the value to 250. Now if I go back to the browser and open this entry, so you can see here that the bottom is set to 300, which is the bottom value of this container, this boundary. The height is set to 50. So since the bottom of the container is the intersection boundary, the height is going to be half of this target element's height, which is 50. So only this section. The left is set to 0. The right is set to 100. The top is going to be the height of this container minus 50 pixels, which is about 250. The width is again 100. X and Y will be again equal to left and top. The second option is the root margin. So let's set some margin for our root element. Now as you can see here, it's not a CSS property, so there are not going to be any visual changes, but it's more of an imaginary margin attached to the root. Inside root bounds, let me just open this up. You can see that the left and the top are now spilling out. The left is now minus 10, that means this is the container, and since we have a 10px margin on all the boundaries, the left is now going to be 0 minus 10, which is 10 pixels. Same for the top boundary, so it's going to be 0 minus 10, which is 10 pixels. The right and bottom will have 10 pixels extra, so 310 for both of these boundaries. So since there's extra margin at the bottom of this container worth 10 pixels, the intersected area for this target element is also going to increase by 10 pixels. So it's going to look something like this. There will be 10 extra pixels at the bottom. So the height now is going to be 50 plus 10. That means this half portion plus 10 pixels. You can see that the height is 60 and the left, right and top values are going to be the same. Finally, we have the threshold option. Let's just get rid of this container. We'll let it default to the viewport. Inside the HTML, I'll just comment these out. Also inside the styles, let me just move this back to 1000 pixels. Now, as I had mentioned earlier, the threshold will be the point when the callback gets triggered. By default, it's set to 0, which means that the moment any part of the target element becomes visible, the callback will be triggered. It goes up to 1, which means the exact opposite, as in when the entire target element becomes visible, only then will the callback get fired. So let's test this out. I'll set the threshold inside the options object to 1. When I try to scroll, you'll see that the intersection has already happened, but there is no new entry. This entry is what we get when the target element is registered inside the observer. There has been no new intersection entry, even though the target element is already part of the viewport. If I scroll further, you'll see that the callback has still not been fired. If I scroll all the way till the bottom of this page, then you'll see that the callback gets fired. So yeah, when you set the threshold to 1, it's only going to trigger the callback if the entire element is visible inside the container. You can also pass in multiple threshold values inside an array. So it will basically run the callback at those specific intervals. So let's pass in an array instead of this value. The array will have values such that it will trigger a callback whenever there's a 20% intersection. So 20, 40, 60, 80 or 100% is when the callback should be triggered. So for 20%, it's going to be 0.2. For 40, it's going to be 0.4 and so on. Now, if I go back, let me just reload this. I get the first intersection entry. Now, if I slowly scroll down, the second entry has been registered. This intersection got registered because the element is now 20% inside this viewport. If I scroll even further, you'll see that another entry has been logged inside the console. And if I go all the way, then you can see that in total 5 new entries were registered after the first one. So for 20%, 40%, 60%, 80% and 100%. Finally, again, similar to what we saw with the mutation observer, the intersection observer also must be disconnected after usage to avoid memory leaks. There are actually 2 ways to do it when it comes to an intersection observer. One's disconnect and the other one is unobserve. So the reason why there are 2 ways of doing this is because you can observe multiple target elements with the same observer. So for example, let me just clone this target as it is and we'll create a separate new target. So I'll just copy this and call it target 2. Inside the script, let me copy this and we'll also listen for intersections between this target 2 and the viewport. Inside the style, I'll copy the whole thing. Let's call this target 2 and we'll set this to blue. Let me actually set this back to 1 and save this. Now if I go back to the browser, you'll see that this initial callback trigger will now have 2 entries. The first entry is for the target element and the second entry is for the target 2 element. Now if I scroll down, you'll see entries for both of these targets. So my point was that a single observer can observe multiple targets. The unobserved method that we use to disconnect will specifically take a target as an argument, so you can unobserve a single target element and continue observing the rest. Disconnect, on the other hand, stops watching all the target elements for visibility changes. So do make sure to avoid memory leaks by using any one of these methods based on your use case. So I have this simple example here for infinite scrolling using intersection observer. Now that we know how the API works, this should be pretty easy to understand. You would actually be amazed how easy it is to implement it with this API instead of using scroll events with throttling or debouncing. So let me actually go to the HTML first. This HTML will have a container inside which we'll have all the list elements. The paragraph tag acts as a check to see if we have reached the bottom of the list or not. So this element is what we'll be tracking using our observer. Inside the script file, we have the references to the container and the last element. This last element is again the same paragraph tag. The create item function will create the paragraph element with this text. The add items function will append the items created inside the create method into the container. Then we have the observer with the callback. The observer's observe method tracks the last element that we have in our HTML. This callback is going to check if the target element is in the view or not. The reason why I'm using this is intersecting property for each entry is because once the paragraph is in the view, it will immediately render the next 10 items and it will go out of the view right away. So basically I scroll down, the target becomes visible, a callback gets triggered, new items get added. Since new items get added, the target moves out of the viewport. So there's again an intersection, but in the opposite direction. A callback method will again be called. So to avoid this second callback execution, I check if is intersecting is true, which only will happen when we scroll down and it's coming into the view. When it goes out of the view, the property will be set to false. So now if we test this in the browser, you'll see that on scrolling, when we reach the last element, so for this first batch, the last element is going to be the 9th element. So when we read the 9th element, it's going to trigger the callback and we'll get the next batch of elements. So the scroll bar here will shrink in size. I get the 9th element and yeah, you can see that the scroll bar has now moved and shrunk in size, which means that there are new elements here. And this keeps happening as long as you keep scrolling. So it's that easy to create this infinite scrolling section with the intersection observer. And yeah, that's pretty much it for this video. I hope this was informative to you, as I've covered almost everything that's fundamental to this API. Try playing with it and see if you can improve your projects by integrating this API. If you have any other topics that you want me to cover, do leave them in the comments and I'll try my best to cover them. Yeah, see you in the next one.